In the last video, we started our discussion about the completely randomized design, and we looked at how the design is implemented in practical sense. So now we want to see how do we analyze the data after we have conducted the experiment using completely randomized design. And the first example I'll be looking at is a situation where we have equal replications. So we'll be looking at how to analyze CRD data with equal replications. So that's the first thing we are looking at. So the practical example we want to examine is a greenhouse experiment to compare cowpea cultivars. A greenhouse experiment to compare cowpea cultivars. So let's see what the experiment is like. A greenhouse experiment was carried out to compare the yield of three different cultivars of cowpea. 15 pots filled with sandy loam soil were available for the experiment, and these were grouped into three so that there were 5 pots for each cultivar. 3 seeds were planted per pot and thinned to 1 plant per pot at 10 days after sowing. While the experiment lasted, all the 15 pots were subjected to the same conditions in terms of fertilizer and insecticide application, irrigation, and weeding. The yield of each plant at 80 days after sowing was taken as dry matter accumulation of pods in grams and recorded. So look at this experiment that has been described. We have 3 different cultivars of cowpea. That's the only source of variation there that we can see. We have 15 pots. All of them are filled with sandy loamy soil, so that's homogeneous. So our experimental units are homogeneous. Then all the other things done, 3 seeds per 14 to 1, all those are uniform cultural practices carried out. So the only source of variation in this experiment is variation due to the 3 different cultivars of cowpea used. Every other thing is homogeneous. So this is a classical example of a completely randomized design experiment. So let's see the result we have. So our data are as presented on the screen. We have pots dry matter accumulation in grams. So cultivar A in the first column there, cultivar B, cultivar C. So these are the data, and these are in grams. So they are measured values. There is no need for any transformation of the data. We'll analyze them as they are. So let's see what are the steps involved in conducting statistical analysis using following any experimental design. The first thing is you have to identify what design was used and state its statistical model, the linear additive model with the assumptions. Then you present a proper layout of the experimental data in terms of summary tables. So there should be a layout. And then the next thing to do is to state your hypothesis, the hypothesis you want to test. Both the null hypothesis and the alternative hypothesis, all will be stated. Then you carry out all necessary computations, and that will be followed by construction of the ANOVA table. And once you are through with your ANOVA table, the next thing to do is to test for significance. That means you will decide on which hypothesis to accept based on your results, and then you draw relevant conclusions. So these are the steps to be followed in analyzing data, whether it is completely randomized design or any other type of experimental design. These are basic steps that are common to all designs. So it's very important to take note of them. So we'll follow this procedure as we analyze the data. Remember, these are data, so we want to use this procedure to run the analysis. So the first thing is the name of the design. We have identified the design as completely randomized design because the 3 cultivars are the only source of variation there. And the linear additive model is as indicated, Yij equals mu plus Tj plus epsilon ij, where Yij equals individual observation, the mu is the general mean, Tj is the treatment effect, and Ij is the experimental error. Now, it is not enough to just state the model. You have to define the terms of the model as I have done on the screen. So you have to tell us, what do you mean by Yij, what is mu, what is Tj, what is epsilon ij. So you have to tell us what they mean by showing this. The next thing to do is to state the assumptions. So this model has some assumptions backing it up, two assumptions actually. The first is that the treatment and environmental effects are additive. We covered this in the last video. And the second one is that experimental errors are randomly and normally independently distributed with zero mean and constant variance. I already explained this in the previous video. So this is our layout. Remember, we have 3 cultivars and these are the data set ending with 24.2. So when you prepare layout, what you are doing essentially is you are calculating the total. So here are the totals for cultivar A, B, and C. Then the number of observations, you have 5, 5, 5. So this is what we mean by equal replication. There are some times when you use completely randomized design and the number of observations will not be the same. So in that case, we'll be talking of unequal replications. But in this, our example, we have equal replications. That's what we have here. And then the mean, which is obtained by dividing the total by the number of observations. And that's what we have here, the means. So this whole table is our layout. That's very important. The next thing to do is to state our hypothesis. So there are 2 hypotheses to be stated, the null hypothesis and the alternative hypothesis. So simply stated, our null hypothesis is that there is no significant difference in the yield of the 3 cowpea cultivars. And the alternative hypothesis is the exact opposite, that says that there are significant differences in the yield of the 3 cowpea cultivars. So don't forget, null hypothesis is the hypothesis of no significant difference. And the alternative hypothesis is the exact opposite of that. In the next video, we will illustrate how the computations are carried out. So join me in the next video.